That's why I don't really feel that bad about it, because I knew what to check. All right, here we go. The complex zero, 1 minus 2i is a zero of this function. Find the remaining zeros and write a linear factorization. I'm waiting on people that write down the notes to write it down. It is going to take a lot of work.
Whoever sat down and made every single one of these lessons and really needed to learn, they have a lot of fun.
Your life. Or spouse.
Think about the person that had to do the answer book, like the back of the book.
I bet they have a lot of fun.
When I was in college, there was a student that was a grad student for one of my professors, and the professor was writing his own book over differential equations, which let me tell you, is some exciting stuff, differential equations. But the grad student was earning credit for a class by doing the back of the book for him. And so I always say, like, sometimes the back of the book is wrong, and I always say, like, it was usually a grad student that did that, so, you know, I don't really know if the professor actually checked all his work to make sure they were all the right answers. But that's like the worst job ever, I think, to write all the answers in the back of the book.
Unless you only have to do the odd problem.
Well, then the teacher book has the even problems in it, too. What if I said 2 was a 0? If 2 is a 0, find the remaining zeros. What would you do? Could I synthetically divide 2 out and then see what's left?
Yes.
Oh my gosh, let's do that with imaginary.
What? Divide imaginary numbers.
Yeah.
Do that.
Put 1 minus 2i over here. You're going to need a little space here, so don't think you're going to spit all this on one line. Like, you're going to have you're going to have I stuff in here, so don't, like, leave some space in between your numbers. Okay, so when I do this, I'm going to do 4, and then I'm going to write 17. Oh my gosh, I forgot the 0. Wouldn't that be terrible if I did this whole problem and forgot to throw a 0 in?
Yeah, I'd probably just give up on that.
Luckily, I caught it. This is going to get ugly, okay?
It's like learning a scholarship.
Bring down my 4. I'm just saying, it's doable, but here's the frustrating part. You make one negative mistake, it's all a mess, right? Multiply 4 times 1 minus 2i. What would that be?
4 minus 8i.
And then if I add that to 0, that's just 4 minus 8i. You agree with that?
Yeah. Thanks.
Now what do I have to do? Now I have to take this and multiply it by this, which means I have to FOIL it out, right? So I do that in the margin of my paper. If you want to do it on another sheet of paper, you're just super cool and can do it in your head. That's awesome too. I'm just going to do it over here, and I'm going to say 1 minus 2i times 4 minus 8i. So I'm going to get 4, and I'm going to kind of FOIL this in my head. That's minus 8 and minus 8. That's minus 16i in the middle, I believe.
Minus 1269.
1269? What do you mean 1269?
No.
This is why those are legal calculators that you should not be using on a test. And then that's plus 16i squared, which is really minus 16. So she's saying 4 minus 16 is negative 12 minus 16.
I thought you said 69. I
She
was
said
like,
1269, I think.
no, it's 69.
I heard her.
I said I heard that.
Illegal. Illegal calculators.
Legal math. All out.
Here's what good news and bad news. We know this is a vector, which means what should we get down here?
0.
We don't get 0, we know we've done something wrong, which is kind of frustrating because then you're like, you know you did something wrong, right? No, this one works. I've done it before. When I add these together, I can add 17 plus negative 12 and get 5 minus 16i. Yes? Oh, I get to FOIL again, right?
Who thought of this?
Who thought of the need to do this?
Exactly.
Someone that loves math.
Like, when are we gonna use imaginary zeros on mine?
In electrical engineering.
I think I'm not gonna do that.
Anybody here can do electrical
In vectors. I learn vectors sometimes. Talk about vectors. 5 minus 16i minus 10i plus 32i squared, which is really just minus 32. So is that negative 26i and 5 minus 32?
Negative 27. Look at us go.
Negative 16 and negative 10. See how if you make one mistake, it's frustrating, like you just want to wad your paper up and throw it at someone.
Yeah.
Not me, but.
I just wanted to put on
14 plus negative 27.
negative.
We should know we can get negative 65 tonight.
So here's where you can, this should give us negative 65. I think it's smart to actually check. Or you could just say, I did my math right. I'm just going to put negative 65 here.
No, it's a zero. So it's a zero down there.
We know it's really true.
Like the Italian just said he gives up, and I think we're saying that was still zero.
I'm going to show you that it works.
What's 13 times 2?
16.
26. 26.
There's 16. Yeah.
So I get negative 13 minus 26i plus 26i. That's a good sign.
Cancel.
Plus 52i squared, which is really minus 52. Negative 13 and negative 52 is negative 65. So that verifies I did that step right. Whew.
Good job. You did it right.
How do you?
It also says find the rest of the zeros. If 1 minus 2i is a 0, what else do we know is a 0? 1 plus 2i. Let's do it again.
Wait, why do we know that? Why do we know that 1 plus 2i is 0?
I just spilled coffee on my pants. I was so excited.
Why did you say that 1 plus 2i is 0?
You missed this yesterday, Grady.
Why did we
Complex conjugate.
Complex conjugate. If one imaginary number is a 0, then its conjugate has to also be a 0.
And we know already. We know it's a 0, so why do we need
Because we have to see what's left. We need
I
to see
remember
what's
that from
left.
BMAC last year.
How many problem homework is this?
Here's the good news, kids. This is the hard step. Because once you take the 2 imaginary zeros out, we should have no i's left. Which means this step is much easier, okay? It looks awful, but it's much easier. So here we go. 4.
That's my favorite step right there.
Watch how nice it is. If I take 4 times 1 plus 2i,
It's 4 minus 8i.
it's 4 plus 8i.
Come on, Grady.
0.
Get your stuff together.
8. I like what you're doing here.
Whoa.
This is my favorite part. I like
You with me on that? Because
Negative 8.
Where
Oh, I got it all.
where the 8 comes from. 4 plus
Why is it a negative? Wait. Oh.
what do you want to do, Bradley?
Yeah.
You can avoid all of this if you take the two vectors with complex conjugate, multiply them together, and multiply it out.
Which is still a ton of work, right? And I agree. It's the other option,
Imaginaries.
but people struggle with that as well. The one, what was it? Number 6, 3 on your homework yesterday where they gave you i's like this. People struggle to work out x minus 1 plus 2i times x minus 1 minus 2i. So it's true. The other option is, if you don't want to do this synthetic division with i's, is step 1, you got to FOIL this out. Not FOIL, distribute it out. Cancel everything out, simplify it. You get a quadratic. Step 2, you got to long divide the quadratic with this and long divide correctly and not make any mistakes with your negatives. But you're right, you get the same answer. And I don't do it that way because people make tons of mistakes multiplying this and long dividing. But if you want to do it that way, you're totally, it works. I find it to be just as much work, and I FOIL better than long divide. People make less mistakes usually. But you're right, it totally works that way. Because the worst step on this one is the first one, right? Like, this is hard, But now look how nice this is. Like, it's working out perfectly that now I get 13 plus 26i to get a remainder of 0. It has to, or we did something wrong. Because those have to be the zeros. But you're right, you could work this out in long divide. I think it's the same amount of work, if not more work. Just depends on what you like. But I agree. I always like when someone notices that you could do that. Oh my gosh, why won't this work?
I had in the eraser spot.
Well, this doesn't matter, it's just...
Hey. Stop.
We're still not done, right? Because we have to find the remaining zeros, which if you do the long division and you get what's left, then you still have to find the remaining zeros from that also, which you should get if you do the long division. 4x squared plus 8x plus 13.
That's such a description of quadratic.
Which means I probably would just go ahead and do the quadratic formula. We could take 4 times 13 and try to figure out what would give me 8, but it might not be anything. So, this is the problem that never ends. B squared would be 64 minus 4 times 4 times 13 over 2 times 4.
Seriously, I mean, there's 8 sticks in.
Yes, you're right. There's a 52 card pickup.
That too. They're just kind of
When we do probability, there's lots of questions about decks of cards, and I'm always surprised when people don't know how many cards are in deck. Because when I was a kid, my stepdad would be like, "Hey, you want to play a game?" And I'm like, "Yeah." You play 52 card pickup? Okay. And then he throws all the cards on the ground. It's like, figure them out.
I wouldn't do it. They used to ask me now to do it.
I played Smoker Fire with my little sisters.
Oh, God.
They like bend the cards, and then you pull it, it's red, it's black, it's smoke, and then it's fire. When it's fire, you like let the cards fire.
Oh, that works out so nicely, right? Negative 144.
So can you do 12i on that?
Yeah, so that's negative 8 plus or minus 12i over 8.
7.
We can simplify this. You have a couple options. One option is keep it one big fraction, and they do all have a factor of 4. So we could say that's negative 2 plus or minus 3i over 2. The other option is you could break it up as negative 8 over 8 plus 12i over 8 and simplify them separately. I'm okay with that as well. But I'm just going to leave my zeros
This
like
is
this.
a problem when we got 3 answers of all this.
We really got 4 answers, right? Because it says, find the remaining zeros, which we knew was 1 plus 2i in this. But it also says write them as linear factors. 1 plus or minus 2i. Notice all 4 of these were imaginary zeros. Right? PRZs would not have helped us on this, which is why it's nice they gave us one of the zeros. Linear factors, you just change all the signs. So you'd get x minus 1 minus 2i, x minus 1 plus 2i, times, and then again, this is where you can decide if you want to simplify it or leave it or whatever. X, if you change the sign there, that's going to change it to plus 2 minus 3i all over 2, or x plus 2 plus 3i all over 2. And I guess I was moving the 2 up and making it not a fraction, but I guess the back of the book is pulling out the 2s and making it 1/4 in front. I don't care. But after all that work, let's just leave it like this.
That's it.
That's exciting, right?
What is math 136?
College algebra.
It's called math.
That's the number. Like when you take classes in college, they're all numbered. Yeah. And next semester, Math 137 is the same class that you guys are going to get credit for next semester.
So we don't call it precalculus.
Well, we'll still call it pre-cal. Because it really is what we do. Okay, moving on. I'm done with this stuff. I can't handle it anymore.
So we have to write all that?
This is lit.
Yeah.
I stopped there.
So how can we make life more confusing in math class? Well, yesterday we talked about a linear factorization and that we want to be able to write things as linear factors. Well, then they decide that's kind of ugly. Sometimes that looks terrible. So then they say, well, what if we write it as linear factors, but then if it's going to be ugly, we're going to call them irreducible quadratic factors? How ridiculous is this? This actually is, I know. This is actually easier, but again, it's all about reading the directions, which means if they give you these directions, use irreducible quadratic factors. That means don't give me imaginary numbers. No imaginary solutions.
Really?
Yeah, which actually makes life simpler, but it's making sure you understand what it's saying. Irreducible quadratic factors means if it doesn't factor nicely, you can leave it as a quadratic, which means less work to do, which is nice after that terrible problem we just did. You're right, Grady? So stop picking at it. If you want to just kind of shorten these directions, you could just put right with irreducible quadratic factors, so that way you know that that part is part of the directions.
Wait, when it said as a product of linear,
Yeah, and irreducible quadratic factors.
well, that was all one part.
Yeah. Anytime you see these directions, it means if it's not factorable, you get to stop, which is super exciting. Which means less work, which means no quadratic formula. If it's factor it out into the linear factors, but if it's not factorable, we're going to say it's irreducible, and we can leave it as a quadratic.
I like factoring.
Me too.
Not,
Yesterday in Algebra 2, we started chapter 9, which is rational, where you get to like factor and cross everything out, and I said it's my favorite chapter, because I get to factor, which is fun, and I get to cross things out, which is super fun. And I was like, I'm seriously not lying when it's
I
my
like the
favorite
long one
thing.
we have to go about the first and second. I can never remember how to do that.
Makes me so happy.
I just like the time where it's like x squared plus 2x.
Yeah, but I don't know how to do it.
Yeah, those are my favorite.
So on problems like this, again, step 1, PRZs, find something that works. Great news. We don't have much to check here, right? Plus minus 1, plus minus 2. So if I plug 1 in here, I get 1 minus 1 minus 1 minus 2.
Nope.
If I plug negative 1 in here, I get negative 1 minus 1 plus 1 minus 2. If I plug 2 in here, I get 8 minus 4 minus 2 minus 2.
Yeah.
Right? Not impossible to do. You just got to know the process, plug them in. What do I do to find one that works?
Division.
Divide it out.
I also like something to do with step down. I don't hate all of that.
So here's what's super nice about these.
You're done?
Can I factor this?
No.
Which means I don't have to go any further. That's an irreducible quadratic factor. And what was the other 0 that we had that worked?
2.
How would I write that as a factor?
X plus minus 2. That's it. This.
I like these better.
That's super great. Why don't we just do this all the time, right? Because we really kind of want the zeros. Do another one? Can I admit something to you that you're all going to groan about? I forgot I printed your notes out.
Did you really?
Hey, you know what? Problem.
I have them over here, and I just realized that when I was like, oh my gosh, I'm worried about time. We're never going to get done. And then I was like, oh, I just remembered I printed your notes out. Failure.
6 and 12. That's too many options.
But then again, I'll have to learn this in my homework, and I need 100, so yeah, we should do it.
Yeah, you can do it.
You can do your homework. It's on the homework.
No fractions, that makes it better, right?
You know what happened last night? I won $2 on a lottery ticket.
Hey, are you even? Oh, yeah, I
I
guess you
got turned 18 yesterday.
I remember it was
What
Mother's
does
Day.
it cost?
Sorry.
$1. Made
Oh.
profit.
I tried that.
I only bought, well, I didn't buy it, but I only got 20. But I won $2, so that's all right.
Oh look, I think negative 1 works.
Let's take some regular back. We're talking about math things.
You shouldn't play lottery. You'll just get addicted.
I had to. It was just like you have to do
No,
that
but I used to work at Kroger, and there really were people that were addicted to the lottery.
That'll be me though.
Nathan Chris last year, I taught him to play Yahtzee in college algebra, and then he became obsessed with Yahtzee, and then somehow that led to scratch-off tickets, and he seriously would like go and buy like 20 scratch-off tickets before school, and bring them to school and be like, here, scratch these off. And I'm like, seriously, Nathan, I think we need an intervention. Like, stop spending all your money on lottery tickets.
I'm gonna use my $2 to buy 2 more because $2 won't get me much. So I might as well try again.
If you ever win,
Yeah, but
if you
If I
win,
win over 10, I'll keep it.
That's $2 plus if you ever win.
But I don't have any more money because I was given $2.
You have no money to your name. You're 18 years old. You bought lottery tickets.
My mom bought it.
oh, does more work for birthday?
Well, that's my brother.
No, I think.
Oh, you're right, thanks. Look what's left on this one, and again, you don't have to do it this way, but I like to factor. So when I look at this, I see factor by grouping, I think would work to solve the rest of this. Do you agree with me on that?
Yeah, maybe.
Because I could factor out an x squared here, and I'd be left with x minus 3.
I just do it.
And if I factored a 4 out of here, would I be left with x minus 3?
Wow.
That doesn't work all the time, but when it works, it saves you a lot of time from guessing. And so then I can factor that into x minus 3 and x squared plus 4. Same directions as last time. I want irreducible quadratic factors.
X plus 2 and X
That's
minus
reducible.
It's not reducible because that's a plus sign, right?
I see a minus.
Oh.
You agree if you solve that, you would
It looks
get,
like a minus sign went on my side.
you get plus or minus 2i there. So you can stop there, but don't forget that negative 1 worked also. So I'm going to throw in the factor x plus 1. And we were able to make that a little bit shorter by checking that it was factor by grouping. Not always factor by grouping, but sometimes.
So there's like more B's than there are the one-off, right?
You don't really have to write this down unless you just want to, but I just wanted to leave you with one final thought.
Is it D? No, it's not D.
It says this in your book, every polynomial function of odd degree with real coefficients has to have at least one real zero. And I want to know why can we say that's true?
Edge cross X.
Why?
Oh,
Yeah, and someone said this last year, and I think I never thought of it this way. If it's an odd degree, we know the arrows go in opposite directions, yes?
Yeah.
So eventually, it's going to have to cross the x-axis. I never thought about because of the arrows, so we could say because of in behavior. I thought about imaginary zeros. Can you ever have an odd amount of imaginary zeros?
where do we even? I don't understand that concept. I understand it's difficult, yes. Where imaginary zero? Where's it cross? Don't even know.
It doesn't touch. It's just a solution. Yes.
It just like hurts my head to think about it.
Complex zeros only occur in pairs. So if you have an odd degree function, you could have 2 imaginary zeros, but there's always going to be that one left over that has to be real. If you have an even degree function, could all of the zeros be imaginary? Yes, because it never touches.
So isn't there? I took notice last year in elementary. Isn't there a way to test how many zeros of what kind there are?
We can test how many possible ones there are. Descartes' signs, we also talked about that yesterday.
Yeah,
But it
of course
only
is that.
gives you possibilities. Like you could say 4, 2, or 0, right?
Yeah, I
Yes,
guess. I
yes.
took a that last year. I don't remember
Yes.
what
we talked about that it's sometimes helpful, but sometimes it's just annoying. So we said, well, I said we weren't going to do Descartes' soul signs all the time. You can do it if you want.
I think there's like 77 different ways to spell
You
it.
them here for 2 years.
Only 5 questions. That's exciting, right?
But they
Yeah, but
take
20% of them are a really long time.
33 is a really long time.
the first one, yeah. Maybe I should do it here then. If I get really mad, if they're really hard at me.
You have to try it yourself.
I'm glad it was due for like a week and a half.
Multiple choice, 57 multiple choice. So there you go. 20% multiple choice too.
So 40% is.
You're not gonna do 40%.